Okay, I think we're finally there. We're ready to go into homeworks into spring. I've got a spring 16 of homework, but anyway, September. We'll change this due date. I promise. All right. It was from last semester. All right. So most of this is self-explanatory based on what we did. So all these are nice, straightforward questions. Okay, so here you go. My super duper monosky can go from 0 to 60 miles per hour in 9 seconds. Not the 1.67 seconds of the not the 1.67 seconds of the of the sports car we looked at, the Barabbas there. So anyway, we did this calculation. We did this calculation already. So now don't forget, got to change that to 0.447, right? Okay. It's the power of my Mazda. Okay, that's a good question. Convert your previous answers to horsepower. In other words, multiply by 0.00134. You find the horsepower of my Mazda. Okay, so now I want you to watch the Top Gear video because the next like 8 questions, like I say here, I go off on a tangent. Okay, kind of go off on a small tangent. Now, but this is pretty cool stuff. I like it. So where are we are going to be comparing one of the world's perfect human machines, besides Penelope Cruz. That is so sad. I shouldn't be saying stuff like that. You think it's funny and everything, but I don't know. Anyway, let's find his initial acceleration at the very beginning. He goes from 0 to 9.6 meters per second in 0.97 seconds. What is his acceleration? Remember what acceleration? Change in speed divided by the time. Okay, that's right. This answer is a little more than 9.8 meters, which is 1 g. So Usain Bolt pulls 1 g at the very start of the race. I wanted to make sure you understood that. Let's calculate the acceleration of the Bugatti between 0 and 60 miles an hour. It does this in 2.46 seconds. Now that one car that we looked at, the Barabbas, which is not street legal, did that in 1.67 seconds. Don't forget to multiply 60 by the 0.447, okay? And then take 60 divided by this, or not 60, but like 26.8 divided by the time. Oh my, is greater than 1 g. By the way, later on in the course, we will be talking about dragsters, and they have a 5 g acceleration for a while. Now, let's look at Usain Bolt's average acceleration between 1 second and 4.2 seconds in the race. And I'm looking at that one graph, all right? This is when he was actually doing a very positive acceleration. So basically what I'm doing is I'm looking at that one graph that I showed you in the earlier, but I'm giving you the time. So at 1 second, he was running 5.5 meters per second. At 4.2 seconds, he was running 11.5 meters per second. Acceleration is this minus this. Complete that calculation. Don't go this minus this, then divide it by 4.2 on your calculator. Because what's going to happen is you're going to do this minus 5.5 divided by 4.2, and it'll be all screwed up. Make sure you do the work in the numerator first. All right? And then you find his acceleration. Okay, now let's look at the Bugatti's average acceleration. Like a human, a car can't accelerate forever without blowing up. The Bugatti, starting from rest, reached a top speed, according to the Top Gun video that we watched, reached a top speed of 188 miles per hour in 18 seconds. Using the equation for acceleration from the previous problem, calculate the Bugatti's acceleration. Don't forget to multiply the 188 by 0.447 before you get started, and you're going to divide by how many seconds? 18, right? Looks like the Bugatti can sustain the acceleration longer because it did it for 18 seconds, and Usain Bolt did it for what, 4.2 seconds. Okay. At his top speed, Usain Bolt achieved a top speed of 12.4 meters per second. Unbelievable. They're freaking cheetah. Actually, cheetahs can run for short periods of time at 70 miles an hour. But if he has a mass of 95 kilograms, calculate his kinetic energy when running at this speed. All right, so you've got the 12.4 meters per second. You've got his 95 kilograms, 1/2 m, which is the kilograms, times 12.4 squared, and you should be good. All right, to calculate the kinetic energy. The Bugatti has a top cruising speed of 213 miles per hour. Remember, this is a street legal car. You can probably pick up a used one for around $1 million if you want one. All right, remembering to multiply the cruising speed by 0.447, our conversion factor again, and knowing the mass of the Bugatti is 1,888 kilograms, calculate the kinetic energy of the Bugatti at its, I forgot to put in the Bugatti there, at its cruising speed. Now, let's calculate the horsepower of Usain Bolt. Power equals force times velocity. All right, so anyway, what I did was mass times acceleration is velocity is speed. All right, so what I did was I took his average over the entire thing, 100-meter dash. I took his average acceleration. Okay, basically, I computed what his average. In other words, I computed how much. I just assumed as an average acceleration, and I came up with 1.875 meters per second squared. It was a little bit of a screwy calculation, so I just gave you that. So mass times acceleration times this, so that'll give you his watts. Then multiply that by 0.00134 and you get his horsepower. All right. And then last but not least, while I'm having fun, well, like I said, I'm having fun. How about you? Anyway, let's finish by calculating the horsepower of the Bugatti. Okay, according to the specs I found on Wiki, the Bugatti has 1,184 horsepower. So let's see how close we get here. First, calculate the force of the Bugatti. And the acceleration we computed earlier, just go ahead and use the 4.7 meters per second squared. For when it got up to, we'll assume that the acceleration it was using was that the average acceleration was when it went from 0 to 188 miles an hour in 18 seconds or something like that. Okay. 213 miles per hour. Okay, don't forget. Well, put all that together. Voila! Not bad. You're going to wind up. You're going to get pretty close to the factory specs by doing that. And I think my Barabbas thing, my acceleration is way too high. I probably should. How long does it take to get to it? I should have looked up some stuff. How long does it take to get to its maximum speed? That kind of stuff. But anyway, there you go. Have fun with this, damn it. It's physics. You're supposed to have fun. And I will talk to you. I will see you all next week. But I got to update when the assignments due now. Out here.